Propositional model checking in AI involves verifying whether a given model, typically represented as a transition system, satisfies a given property expressed in temporal logic. Effective propositional model checking in AI involves efficiently determining whether the model satisfies the property, even for large and complex systems. Several techniques contribute to effective propositional model checking. 1. Symbolic representation. Efficient representation of the transition system and the property using symbolic representations, such as binary decision diagrams, BDDs, or propositional satisfiability, SAT, solvers. 2. Model reduction. Techniques to reduce the size of the model while preserving its essential properties, such as state space reduction or property-preserving abstraction. 3. Temporal logic. Utilizing specialized temporal logic formalisms tailored for efficient verification, such as linear temporal logic, LTL, or computation tree logic, CTL. 4. Incremental checking. Incremental techniques that exploit previous results to efficiently check subsequent properties or refined versions of the model. 5. Parallelization. Leveraging parallel and distributed computing to distribute the verification workload and speed up the verification process. 6. Abstraction and refinement. Techniques that use abstract representations initially and refine them iteratively to obtain more accurate results. 7. Caching and memoization. Storing intermediate results and reusing them when possible to avoid redundant computations. 8. Heuristics and optimization. Applying domain-specific heuristics and optimization techniques to guide the search and prune the exploration space effectively. By combining these techniques, AI systems can perform efficient and scalable propositional model checking, enabling the verification of complex systems in various domains, such as hardware design, software verification, and protocol analysis.